Hey everybody, it's Guy McDoodfellow, co-chair of the B-Sides Las Vegas Proving Ground track. Our next talk is Revisiting the Analog Hole, using OCR and other techniques to exfiltrate data by Samuel Greenfeld, who was mentored by Lucas Morris.
The analog hole refers to the fact that despite the fact we use digital signals and encryption nowadays, data has to be eventually provided in an analog format that can be heard or seen by an end user. I'm Samuel Greenfeld. I've been a software code engineer for quite some time. I've been CSSP certified for 11 years now. I'm here to talk to you about how optical character recognition can be used to extract data from an environment. In this talk, we'll have an introduction to optical character recognition, discuss how OCR works, look at some results, consider some related attacks, and also consider some countermeasures. Optical character recognition in general refers to automated methods to identify printed or handwritten text in an image. It existed in a crude form as long back as the 1800s or early 1900s, when portions of characters are converted one bit at a time into audio for use by the blind to interpret text. It started with targeted characters and fonts and now much more general, and it's a very mature technology. If you look at many optical character recognition programs from the 1970s, they look very much like their counterparts today. Why should we look at optical character recognition? It's a widely available technology. It can be done outside of a system, so you have no clue that it may have occurred to your data. Users have to be able to interact with text. You can't obscure it without slowing down their progress. Text tends to be a limited number of colors and sizes, making it easy to extract from an environment. Image precision is generally not super important. We're not attempting to reproduce an object given a picture of it. You can remove non-text data, which can be used to identify the source. And the focus tends to be on large data breaches, but smaller data breaches may be dealt with quietly or potentially lead to bigger ones. The COVID-19 pandemic has led to a surge in remote work, and you do not necessarily see what your employees are doing. This makes it much more easy for them to use a smartphone, camera, or other device to take pictures of data from a computer, and your company-issued laptop may not be able to log or otherwise identify that they have done such of a breach. What is the business impact of this? You could lose user data such as addresses or credit card information. Users may not get rid of all of the data, may not leave your company, but you potentially could lose a portion of it, similar to a credit card skimmer at a gas station or restaurant. You could lose company data such as your battle card information used for processing with your competition and how you're going to deal with them, or potentially pricing information, which could then lead to the loss of sales. You could lose operations data such as your access keys or your information on how firewall rules, which could then be used to obscure, potentially lose data later, but not necessarily directly. And you could lose product development information such as future plans that you may wish to work on. Cameras work for monitors, paper, screens, and many other mediums. They don't care what you point them at. Here you have a picture of Samsung's camera application on their smartphones. The T in a circle means it's identified there's text on the screen. As such, it wants to offer you the ability to scan the image where the text is located, and it's conveniently provided a tap to scan button. So how does optical character recognition work? First, you convert an image that you see into black and white or another two-color format, ones and zeros. Most optical character recognitions work in black and white, or they may be able to then reapply the color afterwards. You then rotate the image to a known orientation, normalize the height and width of the text so it matches what you expect, determine the areas of interest, which may be characters, words, paragraphs, or some combination of all the above. Then you process the results. The crudest and oldest technique would be to do an image comparison where you compare a character with a reference and see if it matches what you expect. You can also do a glyph comparison, just again at the character level, where you separate a character into its components and then identify the letter that way. More modern systems will use neural networks such as short-term memory networks, which will attempt to take entire words perhaps and identify them with and output a confidence interval. But if you're doing this all with a 3D input, such as a camera from outside of the system, you have to potentially correct the perspective. Note that some systems, such as Google's or Amazon Web Services, video engines can correct the perspective for you, but in case you manually have to do it, you can either use a smartphone app that you pick up the information on, or you can use PaintShop Pro or another application on a computer, and the result kind of looks like this. Some optional techniques you may wish to consider are noise line removal, to potentially remove any noise on the screen or piece of paper which is not related to the text you want to extract. You can do script language recognition, especially if you're using an engine which supports word recognition. There are engines out there which support hundreds of words. Alternatively, you can do layout analysis, which some layout analysis is kind of mandatory, but there are systems which will do things like work with your things, work with your invoices and other information, and then we'll go from there. There are plenty of variable applications for doing this. You may have mobile applications such as Microsoft Lens or Google Stacks, original equipment manufacturer software included with printers and scanners. The Abbey company makes a wide range of software, ranging from cloud-based solutions or stuff you can include with your own product to the OEM solutions mentioned above. Adobe Acrobat makes both cloud-based solutions for their free software, which you can pay on as an add-on, as well as their pro product to do scanning and recognition. And you have a variety of cloud-based solutions from all the major providers, both for images and video. There are open source software solutions which may do this OCR as well. However, you may have to do a bit more pre-processing, and as said, many other solutions. When acquiring data, I've identified two main ways you get data from a computer. The first would be page text. This would be things like database entries as shown, or slides like from a PowerPoint presentation. If this had been an in-person talk, you may have seen people taking pictures with their smartphone of the screen. Alternatively, you can have scrolling text, which can be approximated by using the page text and then hitting down the page down button and stitching the result together. Alternatively, a more advanced solution may be able to handle gradually scrolling text and stitch that together as well. Some results. You have Google Drive and Google Docs here. Here we've uploaded an image to Google Drive, and it offers to let us open the image in Google Docs. And here's the result of that. You can see that it's extracted the text that it's found in the image, and it even colorized it a bit. And it even recognized that there was a table because it went down the fiscal year columns. Microsoft Lens is an example of a smartphone app which can upload to the cloud in the form of a OneDrive-based Word document. Here it's attempted to figure out the same image. You can see it's kind of confused. I've noticed Microsoft solutions don't particularly care for noise. What you can do about this is help potentially pre-filter this or use another product, but this doesn't mean that Microsoft solutions are bad. Instead, it just means that they are more prone to being distracted by certain types of noise. Here's another example where I used Microsoft Lens again, and despite the fact it was skewed and the skew is picked up in the OCR output, it was better able to figure out what was going on. Microsoft Word on its own can also do optical character recognition. Here's the prompt that appears if you give it a PDF file, and it's able to extract graphical-based images with text in them from the PDF file. Here's the result of that. While it did not convert the inverted text from the image we gave it, which was cleaned up to help it, it did convert the text for everything else that's on the screen. In addition to the text-based solution and the table-based solution, Amazon TaxDirect also, and they're part of Amazon Web Services, can also process forms. While it did not spot the member ID, which was inverted, you have the ability in this mode to detect things like the VIP member checkbox was selected, which is not something it does in other modes. Some related attacks. You can simply take a picture. There's no reason you need to run optical character recognition, especially if you're doing something simple. You can do image manipulation prior to OCR. As we said, you can do the 2-character conversion or just extract the text colors in advance to help pre-processing if necessary. Here we're doing that with PaintShop Pro. You can do screenshots or screen shaping. There's nothing special you can have to do here so long as you can easily get the image or other information out of the computer without being detected. This may be harder depending on what your employer or the computer you're trying to access is attempting to do to keep you from easily extracting data. You can do source video capture using an HDMI capture device or another video capture solution. Here we have Open Broadcast software being used to take a capture of the PowerPoint screen. And if you have access to the computer, again, you can do advanced things like potentially, if you have the ability to use the accessibility framework for the operating system, which is typically used for either test automation or the users who are disabled, to extract the information from an application and easily make the text and potentially other information available to read. Here's an example where I pointed Microsoft's test utility called Accessibility Insights at Firefox, and it dumped all the text it found in the document we saw earlier. You can also infiltrate data potentially. This may be easier for things like invoices and business cards, provided you don't trip any alerts that the invoice is obviously something odd, like you spent $5,000 at a restaurant. But infiltrating programs is much more difficult. Here we have an example of one of the few programs which is purely in text-based characters, which is an antivirus test file called ICAR, but it does not easily get processed by many optical character recognition engines. The reason for this is because many optical character recognition engines expect there to be a known language of text, and so they attempt to take this string and insert spaces, figuring there must be spaces between the words. They may turn the parentheses into brackets, potentially get confused, like the I might be a 1. And this in general is the problem you have to deal with if you're trying to do stuff like that. In general, if you're trying to infiltrate something like this, or potentially base64 encoded data, or you're going to have to have very good control of the computer you're trying to implement this with. Otherwise, you're not going to be able to control the company's computer enough to the point you can get systems in there and you're going to probably trip a whole bunch of alerts provided they have for the proper configuration to detect these sorts of things as well. On the other hand, you could potentially look at something like an encryption certificate in base64 encoded data, and provided they didn't have an alert triggered on you doing that, you could potentially, at your whim, control the optical character recognition on the remote side and then decrypt and potentially base64 decode that data with ease. Some countermeasures to OCR you could consider. Visual watermarking. The main thing here is that watermarks in general have to be done in a way that are not obtrusive. So if they're a different color like they are here, you could easily just extract all the black text on the screen and get things done that way. And alternatively, if this had been an embossed watermark, you may have had a bit more difficulty, but may require some pre-editing, but in my attempts I was able to OCR with that. But if you took something like this page, printed with a black and white printer, at least personally, I would have a lot more trouble using a black and white laser printer's copy of this image and attempting to extract the text. You may attempt to avoid direct recording, provided you have enough control over the computer, such as using high bandwidth digital copyright protection, enumerating the attached video devices to see if one's known to be a recorder, discriminating the screen capture of the operating system, and other means of potentially blocking that. However, this does not stop someone from putting a smartphone or other camera device at the computer and indirectly attempting to get at the information that you're attempting to block direct access to. You can limit the data breach. This can be done by only showing a limited amount of information to users. It could also be done by showing different data to different users. This does not necessarily mean just between a supervisor and a lower level employee, but if you have something like a customer service representative, you could have your test callers use different names when talking to different representatives. So if there is a data breach, you can potentially trace where it came from. And there are corporate countermeasures. You can use corporate policies and training to discourage indirect attempts at extracting data. You can do employee monitoring to attempt to see what you're doing. But even if you monitor webcams, various online test providers have found there are ways that people have found to point a smartphone at the camera, even if they first point their webcam around the room and claim there's no smartphone or other camera device around. And you may also have endpoint data protection or data prevention loss solutions. These may not help except in the direct case where someone may be trying to email a photo to themselves, but they may also give you log activity in retrospect to figure out where a breach may have come from. That's my information in terms of what I feel about optical character recognition. But in conclusion, if a human has to see it, then other devices have to capture it. Optical character recognition may help perform a medium-sized data breach, but may be too complicated for potentially smaller and larger compromises. If all you're looking to do is grab someone's email address or one-slide information, there may be no point to doing optical character recognition. But if all you have access to is like a Citrix or VMware Horizon or another remote desktop-based solution in a graphical window, and there's no other way you can potentially extract the data from the environment, such as a mass database export, then optical character recognition may be your only way of extracting all the data.
All right. Well, we're here with Sam. That was a utterly terrifying talk. I always love data exfil talks because they inevitably cover ground that nobody else seems to think of or worry about. One question I did have is discussing more mitigation strategies. I know it's difficult because cameras are everywhere, smartphone cameras are everywhere. But what are some potential mitigation strategies that organizations could use to try and defend against this sort of thing?
Well, it obviously is suggested you could possibly limit the amount of information that anyone sees and keep log who saw what. As we said, you could also potentially use if it's obviously a classified information facility, you may have a SCIF or something where you're restricting access, or an exam room where you are. But if the user is remote and you don't have visibility into the room, even just if you're like an exam provider and just having them wave their computer around the room, that might not be enough to catch it. They're holding a smartphone under their laptop.
What about situations where, well, I'm trying to figure out how to frame this question. So we've talked about users taking pictures and using various OCR platforms to exfil data. What about situations in which we're pulling data directly from a user's device so let's say the user's got malware on a phone, because we all know that that's a potential problem that we're gonna have to mitigate. So what about cases where you're just basically, anytime the user's taking a picture, pulling stuff like that, pulling whatever the photo is into something in AWS or Azure? What about setups like that?
Oh, you mean where the malicious malware is intentionally taking photos of the screen? or as a disaster
Yeah.
recovery technique.
Well, or, basically you've got malware set up to anytime to monitor the phone and grab a copy of whatever the user's taken a picture of. I take photos of receipts all the time.
True.
Right.
I mean,
so what about situations like that?
You could definitely use OCR potentially in such a situation, or you may be using more intelligent software to figure out what is the user trying to do that they're taking pictures. Oh, they may just be randomly taking pictures of their dog or whatever. An interesting twist on that situation also, as I've noticed, at least in some cases, although I don't know if it's intentional or not, at least one smartphone platform I know of, if you're in a work partition on Android and you take a screenshot, it ends up in your non-work partition with the personal data. And I don't know if that's intentional on their part or not.
And I suppose using things like MDM and other mitigations for BYOD don't necessarily defend against this type of attack, right?
Well, if the MDM is on the device, it potentially could say no screenshots, at least through the official channels. I mean, I believe there are like a lot of the apps out there that try to do disappearings like Snapchat and stuff. I thought try to avoid screenshots as best that they can. But
Signal does some mitigation like that as well.
It's just in general, all you need is another device that's just pointed at the first, and your mitigations kind of go out the door.
Right. Well, what I was getting at is with MDM, turning off the camera on the smartphone disables essentially 1/3 of the utility of a smartphone, right? Having a camera in your pocket is a game changer, and not being able to use that camera for things like taking photos of, stuff like that.
I believe you can also have Apple officially remove the camera from an iPhone, at least for government use as well.
Right. There's also, putting a brightly colored sticker over the camera, but that's easy to replicate or reverse.
Tamper-resistant sticker.
Now, I know that for a long time, there have been counterfeiting countermeasures in Photoshop and in HP printers especially, but basically there are programs where Secret Service and the Department of the Treasury work with manufacturers of printers and various graphics software that prevent you from doing things like scanning in a
as well as I believe it's the Echelon constellation or whatever it's formally called, which is this all the pattern of yellow dots with their some of the relative distances all equal to some square root or something. I have to look up I don't remember it live for this talk, but yes.
Sure. But mitigations like that, how practical are those to prevent this sort of attack?
Well, you're presuming the currency stuff primarily just kicks in when you're trying to work with currency or turning your photocopy of it into just a black thing. And if you screw up enough times, eventually the copier locks up with a service code that gives away what you tried to do. But in general, if you're just looking at, if it can avoid the original picture, yes, potentially. Though I don't know, I'm not aware of any cameras that necessarily implement software that implements that directly. It would have to be something like if your OCR solution is once you have the text, there's nothing that any sort of watermark can do unless you've explicitly put watermarks like slight variations within the text.
Okay. What about, not necessarily in terms of mitigation, but adding sort of forensic trails? You see this especially in the screener films that the Academy of Motion Pictures will send out to Oscar previewers, right? They will put in not only like the sort of promotional consideration only, but they'll put in certain frames.
In general, I would think with watermarks, yes, the original photo will always have the watermark in it, but once you've done the text extraction, it's kind of harder. In fact, I think, for example, one of the leakers of classified information from the government earlier this decade was part of their prosecution message commented that the press that they recopied their stuff you actually copied it down to the little yellow dots, printer dots on the page when they uploaded a copy of the scanned leaked information to their news website. Since then, that site I've noticed has also instead does things like they'll provide quote quote reconstituted information. So it's your initial if you can trace the initial leaker, you'll get it. But once you've passed through the RCR filter, it's a lot more difficult to potentially figure out your watermark unless you've intentionally given them different text.
Well, and there's also patterns. Like people write in certain ways. People use the same turns of phrase and the same spellings and stuff like that. It's a common thing with my spouse, who's a university professor, to check for plagiarism by running it through various tools. I know that some of that has the potential to be added to DLP solutions.
Yes, for some of this, for the purpose of this talk, I wasn't necessarily thinking of tracing individual emails. I was thinking primarily, although I guess you could potentially leak individual emails or keep track of stuff for potential claims against your employer later in case you were mad at them or something, or just your contacts you were as a sales guy. I thought of it more in terms of this is going to be information that's potentially critical to employer, but it's kind of mass produced potentially within the organization, or at least pretty widely spread or accessible within the organization for the most part.
Okay. Well, is there anything that you didn't get a chance to cover that you'd like to touch on in more depth?
I kind of thought about a bit more. I didn't really cover the press of this in the actual talk. One thing I'd point out is, well, you don't necessarily see a lot of optical characterization mentioned apart from breaking captchas and potentially filling in login forms I've seen done is another example. Well, you see it a lot more discussed on the potential side of defending against leaks or AI or whatever the OCR solutions come into play for defense more than offense, or is just software you'd want to use around the house. But in general, there are plenty of articles out there about leaked pictures, such as COVID-19 vaccination information from the Netherlands, which is out there, where the news has shown redacted spreadsheets of the information that was leaked or attempted to be leaked, and you could have easily used optical character recognition to process it afterwards.
Yeah, the COVID stuff. Especially with regards to vaccination status, that is something that scares me a little bit, because it's so easy to grab that data and forge it. It's not like there are countermeasures embedded in the cards themselves, like you would see with an ID or a passport or something like that. So I think one of the nice things one of the things I appreciate about like the Excelsior Pass and some of the stuff that France is doing is they're not relying on optical verification. They're actually using proper cryptographic sound methods of verifying veracity or of determining veracity. And
even if you go to Walmart, it's going to get, in order to get in one of these systems, such as Common Pass, Walmart actually provide you just a cryptographically signed hash to start with.
Yeah, that's good. All right. Well, thank you very much. I don't see any other questions in the channel, but yeah, this has been a great talk, and it is a fascinating topic, and I really appreciate it. So thank you very much.
Thank you.